First, I want to do electrolysis of a molten salt, which is the easier case. Molten means it's melted. And I took lead 2 bromide as example. So we have lead 2 bromide. It's solid. We use heat, lots of heat, commercially extremely expensive, to give you molten lead bromide. Now what happens is once you have it in molten phase, there are going to be free ions. So you will have lead 2 plus molten plus bromide, 2 of them molten. Now what happens to lead? As soon as you put electrodes of a battery into it or electricity, lead is going to gain 2 electron plus 2 electron. Since you're gaining electron, this is reduction. Since it's reduction, it should be your cathode as an electrode. Eventually we have to draw it. Since these are cations, the cathode should be negative to attract it. And it will give you lead liquid first, then it solidifies. Now if we look at the chart, you will see for this process, you rather need negative, well, this is, let's just write it, reduction, and it's negative 0.13 volt. It's non-spontaneous, so it's saying, look, I need 0.13 volt in order to go forward. Now let's go after bromide and see what happens. Now bromide is going to lose 2 electrons to give you bromine, a red liquid. Since you're losing electron, this is oxidation. Since it's oxidation, it's your anode. And since these are your negative ions or anions, the anode should be your positive electrode. And if you look at the voltage for that, now if we go after bromine, you will see it's sitting here. And you're going the reverse, you're following this arrow. So you're going from bromide to bromine, that means it's also negative. So this oxidation is equal to negative 1.09 volt. If we add the 2 reactions, you will have, the electrons cancel each other out. So you will have lead 2 plus molten, 2 bromide molten, giving you lead solid, free element, plus bromine solid, free carcinogenic element. And if you add the voltage, it's sum of negative 1.22 volt. So it will say, look, I need minimum of 1.22 volt in order to go forward. So let's just draw a battery, electrolytic cell. We need 1 beaker. I'm going to have 2 inert electrodes. In this case, I'm going to choose graphite. So these are graphites, carbon solid, carbon solid. I will connect it to the positive pole of the battery with a big dash line and a smaller one to represent the negative pole of the battery. And I will dip these 2 electrodes into a molten solution. Now remember, your positive was your anode, and bromides, which are your anions, are going to be attracted. So this is the movement of bromide. It comes here, gets accumulated around this electrode. And then you have red bromine liquid, and somehow you have to pump it or drain it out. What happens to lead? Lead, which is a positive cation, gets attracted to your cathode, and it comes here and it accumulates into form of a lead solid. Then again we drain it usually out. This process is extremely expensive because of the amount of heat we need to provide utilities to melt it. Then for sake of IB, you're also going to indicate this is again your anode, this is your cathode, and this is migration of ions within the molten liquid. Molten is the easier part. Now we have to worry about aqueous electrolysis.